Welcome to the Scientific Sense podcast, where we explore emerging ideas from science, policy, economics, and technology. My name is Gill Eapen. We talk with world's leading academics and experts about their recent research or general areas of topical interest. Scientific Sense is an unstructured conversation with no agenda or preparation. We cover a wide variety of domains where new discoveries are made and new technologies are developed on a daily basis. We are most interested in how new ideas affect society and help educate the world how to pursue a rewarding and enjoyable life rooted in science, logic, and information. We seek knowledge without boundaries or constraints and provide unedited content of conversations with researchers and leaders who love what they do. A companion blog to this podcast can be found at scientificsense.com, and this podcast is available on over a dozen platforms and directly at scientificsense.net. If you have suggestions for topics, guests, and other ideas, please send them to info@scientificsense.com, and I can be reached at gill@eapen.info. My guest today is Professor Eugene Santos, who is a professor of engineering and computer science at Dartmouth College. Dr. Santos' work on artificial intelligence intersects with areas of information, cognition, human factors, and mathematics. His current focus is on computational intent, dynamic human behavior, and decision-making, with an emphasis on learning nonlinear and emergent behaviors and explainable AI. Professor Santos has applied his work with the goal of better understanding how we, both as individuals and our society, can best leverage knowledge through AI to improve our world for societal good. He's a fellow of the AAAS and IEEE. Welcome, Gene.
Thank you.
I want to start with one of your books from 2006, Adversarial Models for Opponent Intent Inferencing. This was published in 2006. And you say that taking into account the characteristics and behaviors of one's adversary is essential for success in any competitive activity, such as in sports, business, or warfare. And I guess you can add politics to it now, Gene.
Yes.
Obviously, once enemies are well understood, their actions can then be better anticipated and countered. And to do so, the key is to capture their intentions. You want to talk a bit about that to set the stage for, talking about some of your papers later on?
Sure. So when I talk about intentions here, this is really trying to understand what drives behaviors, what drives people's decisions, what drives their actions. And it's also an essential part of explaining that. I mean, one easy example is that you and I just having a discussion here.
Yeah.
When we start off that discussion, there's all sorts of implicit handshakes, so to speak, of us understanding each other's intentions in context.
Right.
Because without that, when you ask a question, I may answer from somewhere very strange if I don't know your intentions.
Yeah.
So, this applies also on the adversary side, because obviously if you can understand them, anticipate them, then that'll help you better work out what the appropriate future actions for yourself are.
Right. And so there are a couple of models in the paper. One of them is called the BDI, Belief, Desire, Intention model by Bartman. And where he said the intentions are viewed as partial plans committed by an intelligent entity to achieve certain goals, desires based on the perception or knowledge of the world, beliefs. And so as you say, this is something that we do sort of naturally, right? And I guess as we go further into other papers, knowing this intention, whether it's a genuine intention or perhaps not, is a critical component, right, for reacting to something.
Mm-hmm.
And so how do you approach it? You have your own model. You call it, what do you call it?
I call it, well, one of them for the adversary, what I call the adversary intent inferencing model.
Yeah.
And the other model we call the, was it IPC model, which stands for interest, preference, and context.
Okay.
I should say they're both sides of the same coin, because the key here that we wanted to capture is that interest is something that's evolving over time. So these models really need to be dynamic.
Yeah.
So, if somebody is just, focused on this for now and then change focus, your model should be robust to that.
Right.
The second piece, which it's called preferences in one model, and the other one is just simply, called the actions, or, how it goes about choosing the actions. That's also capturing things like, your personality, capturing things on, how you want to go about tackling a problem. And the big piece is the one where is the third that's shared by both, is the context. I'll just simply call it that because you shared both. The other one is called the rationale network. The idea is that what drives it. So all three together are the components to define your intentions.
Okay. Yeah, I was just reading through this. You talk about representing and reasoning under uncertainty. And I have done some work in companies where we have sort of sequential decisions, right? If you think about an R&D program in pharmaceuticals or something like that, which takes about 10 years to get to market. And typically, how we think about that is, so we have stochastic uncertainty in a variety of aspects in an R&D program. But we have to make a sequence of decisions that sort of interact with each other.
Right.
And so from a mathematical perspective, it's a stochastic simulation dynamic programming problem.
Right.
But from a sort of an individual to individual kind of interactions, you're not necessarily looking at sequential problems here, right? You're looking at uncertainty from sort of what you can expect from history.
Right. Yeah. So I think a better way to phrase that, first of all, the first type of uncertainty you can think about is what is coming from the history that can drive just simply the next decision. Now, the one thing we tried to do for this model is that there is a loop where each action is based on the previous actions or the previous results of the actions. And so that was trying to get to that whole notion of how do the sequences occur. This was actually particularly important for the adversary model. The work we were doing back then was, working on, for example, warfare simulation and warfare game simulation. I should say that war games. I'm sorry. So in the war game simulations, it was how do these things unfold? What's the course of actions that they would pursue? So we built from there, and looking back at this model in particular, there are a lot of things that map back and forth. For example, say with some sort of Markov decision process, right? Because that's the sequential process you're talking about. Because each step had to be cut off, and be able to move forward without trying to go back through all the historical steps, because that would have been, computationally difficult on a practical side. But also, of course, much harder to model.
Right. Yeah. So you have sort of Bayesian updating happening both in your decision processes as well as opponents' decision processes, right? So in the war game scenario, again, you have an advantage if you can sort of predict how the opponent is internalizing information and what intent the opponent might have, right?
Right.
And so do we do that in a sort of a war game? I guess this is I would imagine routinely done, but more recently there's computing power is really increasing. We could analyze large amounts of data. So do we have technology assisted sort of predictions of opponents' intent now in a war theater?
I tend to say the following is that it's not necessarily a prediction of the intent because the intent is a very broad item, but there's elements where they are trying to predict that, and they've been deploying that to get a sense that what will the opponent do next. I've heard of and seen different things, like, for example, like how would they deploy some of their assets, or and you've probably run into this in other domains, such as possibly in the business world, is that, hey, I think I see the trend of how they're going to make their decisions. And then intent, I guess I'll jump into this a little earlier. Intent then helps you explain that trend. Because, right, you don't want just the trend nowadays where, a lot of modern deep learning and stuff like that, great at prediction, but you have no idea why they're making this prediction. I mean, they're getting much better. You can look at features and stuff, but still, that's still a long ways from intention, unfortunately.
Right. And then, obviously in situations like that, in complex situations, both in business and in the military, there are always game theoretic aspects to it too.
Oh, yes.
And so it's not just getting the answer, like you say, it's actually understanding why that answer is relevant.
Yeah. I mean, a natural thing that you and I are in the business of decision analytics and stuff is sensitivity, right?
Yeah.
That, we talk about sensitivity a lot, and there's lots of things that's great that we can, if we manage to say, formulate it as a nice optimization problem. But, everything else, no, unfortunately, so far.
Right. Yeah, so this is a related paper from 2012, Intelligence Analyses and the Insider Threat.
Mm-hmm.
And it's actually quite topical with a lot of the news coming out in the last 6 months or so. So in this paper, you say in the intelligence community, the existence of a malicious insider poses a severe threat to information, to the actual analytic process, and ultimately to any decision-making process relying on such information and analyses. An analyst with malicious intent can create irreversible short-term as well as long-term damage that's hard to detect. And so the goal here in this paper is a methodology that detects malicious analysts who attempt to manipulate decision-makers' perceptions through their intelligence reports. So you can think about this, sort of in the government, but also in financial institutions, where we have seen, significant problems, right, with one or two people doing bad things. So you want to talk a bit about the paper?
Sure. This was a problem that, in the work of the intelligence analysts, I mean, people were always asking back then questions such as, not just how do you trust the analyst's report, but they're also focused very much on what is the correctness of the analyst report. Well, one thing that had gotten us thinking about is that it's not necessarily that an analyst report is correct or incorrect per se, especially if you think about that an analyst report in many domains is really their best guess and their opinion, right? And so just because an analyst's opinion is not the same as the other ones, it shouldn't call them necessarily into question. So what we're trying to do is trying to find a way of, is there some consistent feature of each analyst that then we could use to see that, hey, if they've decided to become malicious, or they've decided to have the intention, right, of trying to alter this perception, is that detectable? Can we capture something like that?
Right.
So that was where, for this paper, we focused on the idea of, you could say, sort of their work habits or sort of their analytical habits, right?
Right.
I wouldn't call it full psychological, but it's their process. And we are creatures of habit, so to speak.
Yeah,
so
absolutely.
Alter your process. There's something strange that's going to be there. And so we went about for this one. And one thing I'll say about this, biggest problem we had was the data set.
Yeah.
There is no malicious insider data set. There's very few, especially at the level we're talking about.
Right.
So, but it got us thinking, is that, so what? What if we decide to make sure that how could we synthesize or simulate an insider, a malicious insider, that is. And this came back to, we have to think about intent again. we actually went about this paper where we took an actual set of analysts. It was a set of 7 analysts that were asked to do a question as part of a different project, so we can understand how analysts work, and then took their correct products, or took their quote honest products, maybe a good way of saying it, and how do we make it malicious in a believable fashion? And intent came back into that. We went ahead and defined intentions of why they're going about, even went so far as producing a story. I mean, that was fun. Okay, it may not seem very scientific at first blush, but it was how badly we can fool the system. Okay, and one of the things that we found is that doing this analysis tied back to, say, the intent inferencing system, because what we did was the following in this paper.
Yeah,
we did a user model and user intent model, let's call it that, and track their activities of whether it's an honest analyst or one of the synthesized ones. And then we also took a look at their final reports. So tracking these and doing that, we were able to come up with just a simple idea of measuring sort of the inconsistency or differences between their reports. Right. Now, it wasn't just trying to measure the difference or inconsistency between just for one analyst or something like that. It was looking at the range. If I took all the honest analysts, in this case, we were fortunate. There were 2 tasks that were given to the analysts, so that means that they were generating 2 sets of reports. So now we were fortunate. Now we have a relative measure that we could say that, hey, this report functioned this way and had this particular measure. That is, so we measured the user model against their final report. And so now we have 2 data points, and now we have a spread. Right. And so this gave us not just the spread of a single analyst, but the spread of all analysts that now allows us to at least define some sort of norm.
Right.
And that turns out, with the user model trying to capture their style of doing the analysis, because inside each of these, you'd have things like they'd search for documents, they'd mark up the documents, they'd throw away a document, okay, and they'd pull things into their final report. With that data, we actually were able to detect that the ones that we synthesized, even the ones that were hard for the humans, and I'll have to say this, it wasn't a full-scale human test, but when we looked at it, it was very hard for us to figure out if there was insider or not. It was able to distinguish that because there was enough differences going on. Now, yeah, go ahead.
Yeah, so are you detecting differences from sort of the cross-section expectations, or are you detecting differences more longitudinally? So I take person X, and based on sort of historical data, I have an expectation of what process he or she might deploy, and you're detecting differences from that person's expectation, or both?
It should be both, but given how limited the data is, it was pretty much the latter. That we were just basing it on what is the average difference in the reports across the honest insiders.
Okay. And so I mean, that's so interesting. I mean, presumably, if you have fair amount of predictability there, this is something that could be constantly looking at information and raise red flags in the process, right? It won't be perfect, but it would be quite useful. And I also wondered, Gene, I don't know if you went in this direction, but there could be some extensions to look at. Okay, so we could identify a malicious intent of an analyst. We could also possibly look at a malicious intent of using the information, the user's malicious intent, right? And we have seen a lot of issues like that recently.
Oh yeah. We've thought about that. We haven't pursued that one. Part of it is, that is a, how should I say? That is, I would call that the next level up in terms of, hey, if I'm going to do that, and actually that's related to the next paper, that we're going to talk about, is that it leads up to that, and less so in terms of if they're, I guess maybe the best way of saying this is that it leads up to giving you an idea of how important that misuse of information might be. I'll just say that for now.
Right.
But yeah, overall, I agree with you. I mean, having the intentions, which is why I keep proselytizing it, so to speak, is something that just opens up a whole world of possibilities.
Yeah, yeah, and it's almost like going back to sort of financial institutions. It's almost like you could look at whether there is a problem with the process. So there's information coming in, there's information being analyzed, reported, decisions being made, and these are all done by possibly different people. But the process itself, there could be some malicious intent. We may not be able to assign that to a person, but it might be easier to at least raise a red flag to say there's something wrong in the process somehow.
Right. Very much.
Yeah. Go ahead.
Oh no, I was just gonna say very much so, because once you start raising that red flag and you have the intention that builds a better context around it, why that red flag might be raised, then you can ask more probing questions. I think that's, to me, that's one of the most interesting parts, is that how much of that probing question you can ask, and then how far can you get with it.
Yeah, I mean, it's so interesting. We have a lot of risk management systems in the financial institutions, and none of those systems really measure risk at the personnel level.
Mm-hmm.
So many of the big sort of failures that we have seen are actually done by 1, 2, 3 people in these large institutions, right?
Right.
And
their impact is just crazy.
Right. And so you have a recent paper on this. So it's entitled "Discriminating Deception from Truth and Misinformation: An Intent Level Approach." And you said that deception detection has been studied for hundreds of years. A particularly challenging problem is to not only identify truth from deception, but also discriminate misinformation, errors from deception. And misinformation has generally been ignored in the study of deception detection, but through analyzing the foundations of deception, it may be possible to pinpoint a fundamental difference between deception and all other benign communications. You want to talk a bit about that? I find this paper really fascinating, Gene, and I have number of areas I want to dig deeper into.
Sure. So one of the things that might help out is sort of defining what misinformation, what that term means in the context of this work. Yeah. So misinformation is from the speaker. So is the speaker misinformed? So, some people have a confusion. It said, depending upon your point of view, misinformation could itself be a deception, or could itself, be something malicious. But this one's the speaker is misinformed, and then draw their conclusions from it. So from that, though, it's like, when you have back to the your analyst or your trusted advisors, if your trusted advisors are misinformed, well, in this case, very similar to what we talked about, sort of their reasoning habits, sort of how they look at things, that will just be a natural part of it. That misinformation is like, okay, I thought that the sun was, or the moon was made of green cheese, and no, it's not. And you continue to reason normally from that, so to speak. So in this case, we were trying to look at this and say that really needs to be separated out. It's that intent, and even though we weren't discussing it at the time of when this work was finishing up, things such as fake news, these were some of the elements that nowadays actually, some of my other folks are exploring this, extending from there, and seeing that it's not just fake news for itself, because if all you did is just pass a headline, there's not much argumentation going on. But it's when somebody comes up with a malicious argument that is based on deception.
Yeah, it's the insight for me here is, so you say we posted that deception is a special case of reasoning with the purpose of misleading the listener. And so if I understand this correctly, Gene, what you're saying is that if you take an individual, you can set an expectation of a process of reasoning, and from that you can then say if that individual is using in a slightly different type of reasoning, it actually enhances the probability that it might be for some sort of deception.
Right, right. One of the observations that was here, and one of the pieces is that, well, when we're typically we reason forward, so to speak. I'll just put forward in air quotes for now. We reason forward towards a natural conclusion.
Yeah.
And the element here is that in deception, you're forcing a conclusion. So that was the start. I mean, a lot of people agree that this is usually something happens that, you want to deceive somebody because you want to have this answer in the end. So you're going to try and force to make sure I get the answer by restructuring everything else that leads up to it and supports it.
And obviously, this assumes that the person we are analyzing has some sort of reasoning process. So,
yeah, exactly.
It's possible that we might find some samples where there is no reasoning process per se.
Right.
In which case it becomes totally random. So you say, on the other hand, a communication, even with false content, can be honest if the intent is benign.
Right.
So driven by this, you say we identify patterns in verbal written communications that result from the intent to deceive. So essentially, you can distinguish between misinformation or errors from intentional deception.
Right.
Which
right.
is go ahead. And so how do you how do you go about doing that?
Yeah. The way we looked at it again was the same thing. I'm going to say this. Nowadays we have the ability to examine arguments. I mean, I shouldn't say nowadays we have, but I'll say that a long history, right? If you remember from even some of your early classes as an undergraduate, said, "Oh shoot, I got this logics paragraph, and now I got to reduce in the first order logic statements or something like that." And so those are your basis of your arguments, right? And so focusing on arguments, and there is a very burgeoning field now, because enabled by modern machine learning, it's called argument mining. We didn't quite have that yet, and this is pretty new. I would say that successful argument mining is probably only within the last 4 or 5 years, and in some cases there was work all the way back to 10 years, but not the scale yet.
Yeah.
But with arguments, when we have that, then we go back to your process of reasoning. Is like, how do these arguments chain together? How do these arguments lend support to further arguments down the line, and then to your conclusion?
Right.
So when you have that first as a basis, then the other thing that comes in is that each individual argues differently. Their patterns of how they assemble the argument is going to be differently. So we have to also take that into play. And then the other part is, do we have a history of this? Is there a way to get a history of this? Or if we're fortunate, and this was one of the data sets we were looking at, if we're fortunate, is there a large set of people who've made arguments on both sides that now become sort of, a sort of population norm that we can compare against?
Yeah, so you say here, Gene, we hypothesize that deceptive reasoning can be captured through a combination of 3 patterns: propagated manipulations, of functionality and dependence between inconsistency and untruthfulness. So, we have had sort of the plain vanilla lie detectors for a long time.
Right.
But this is not about detecting lies. It's really detecting how somebody has set out to really manipulate something, right? Really being deceptive about it.
Right. Yes, exactly.
And so
go ahead.
Go ahead.
Yeah, I was going to say, so, part of that is, that's why we have the 3 pieces. The propagation of manipulation is how are we forcing that manipulation? How can we, say, lead somebody down the garden path? That would be the propagation. But the other flip side is functionality. How do I say that this argument or this piece of information that I'm going to throw at you, does it really support things? Is it truly important here? Or is it actually something that, if you look closely at it, it's a distraction? And then the last one, inconsistency and truthfulness. Those are the ones where are they being consistent with themselves? And then untruthfulness is more along the lines of comparing against the population.
Yeah, so I know I was thinking that, again, very topical problem that we have in social media. If you can understand, so there's a reverse problem, right? So if you can understand how somebody is reasoning, then maybe you can introduce information into that reasoning process in such a way that that person doesn't understand that person is being manipulated as well. So there's a reverse problem here too, potentially.
Right. Oh, very much so. One of the things that comes to mind always when we have something like this is confirmation bias, right?
Yeah.
If we understand somebody's underlying reasoning process and how they go about it, then part of it is that we can reinforce their confirmation bias to make sure either they keep that one or somehow break their confirmation bias. That didn't sound quite right because confirmation bias is its own term, but it's how do you change it?
Yeah, I mean, we have such a polarized environment right now. It's almost like the reasoning process used by the two cohorts of people that we have appear to have some common characteristics in it. And whoever is studying this problem could appropriately take advantage of it potentially.
Oh, certainly. I certainly agree. I mean, I'm thinking about, there's a large body of literature out there that thinks about, how a population thinks. It's not crowdsourcing, right? Crowdsourcing is when you want to be able to get a diverse enough opinion so that we have a good sample so that when you finally figure out the answer, it's representative. Okay.
Right.
In this case, the large body of work for something like that can also be potentially applied to the situation where you're very polarized. It's like, can I analyze the different structures of that? I'm sorry, that's kind of moved away from our core one, but there's a lot that can be said there, I think.
Yeah. So you have a machine learning structure here, Gene. So, the first block here is discrepancies detection. And you have sort of two different networks represented here. One is a correlation network, and the other is a consensus network. So what do those things do?
Yeah, so the correlation network is trying to get a sense that if I do have that population, like I talked about earlier, if we have that population, how are the people related to it? Are they positively correlated, negatively correlated, or uncorrelated? That gives us a sense of a pattern. So if we had a new person that cropped in, then it says that, oh, who do they seem to be like? But that's not enough, right? Because we're not sure of what their true understanding is. So here with the consensus network, that's talking about, do the structure of their arguments come together? Do the structure of their arguments match up? So you can imagine that one is focused on the individual, the other one, again, is focused on the population. And so those are the things that gives you some more measures. It's a comparison that we can try and do.
So the agents that you represent here, these are essentially historical data on people?
Yeah, some of it's historical data on people. You could also substitute the current agent, which is our target that we're trying to find out. The new person that comes along would also be considered an agent.
And it could, conceivably, it could also be an artificial intelligent agent that has internalized a bunch of data, right?
Oh, yes, very much so. That's why we use the word agent.
Okay. And so out of that comes some information that goes into the next block, which is reasoning patterns identification. And you have three different things there: propagation of manipulation, functionality, and correspondence between inconsistency and untruthfulness. So again, you want to briefly talk about what those things mean? Propagation of manipulation.
Yeah, so propagation of manipulation is figuring out why a particular argument moves in this way. If this argument is going to be manipulated, this is the effect of that manipulation. So you can imagine that each of these agents, when we have the historical information of arguments they make, that will show you that, hey, this was the base of the argument, and this is how the argument moves along. Now, if it's going to be something on the deception side, it will be part of that thing where we're reasoning from the conclusion as opposed to the conclusion. Okay. Functionality, that's the one where it says that, hey, this agent or this person historically always uses argument X, but argument X doesn't have much relevance to the final conclusion, but it's something they believe that needs to be brought up as whether a side issue or a related issue. So functionality will be trying to assess that level of support. And then the third component, the correspondence between inconsistency and truthfulness, is what I was talking about earlier, is that, is this person, if we had them doing things multiple times and have a little bit of history, is it inconsistent with the way they've been arguing in the past? Now, in the case where we don't have their history, that's where those other two networks come into play, because you're trying to find things that, well, they seem to be similar to this, different to this, and then try and derive an inconsistency from there. Now, the untruthfulness is the same way. It says that, are they, how are they using the information? Are they something that in the past, they tend to use this part of an argument and say that this argument is central to this, and then they suddenly flip around and say this argument is not central to this. That would be a very easy case of untruthfulness.
Right. Yeah. So if you have a lot of data, you can then use some sort of supervised machine learning process. You can classify these things, but in the absence of sort of labeled data, you can also look for patterns in the data, right? So essentially, what you have demonstrated in the paper is that given a problem and an individual, correct me if I'm wrong, if I'm understanding this correctly, given a problem, which could be an analysis problem, which could be communication problem, whatever it is, and an individual, this type of a classification system could assign a probability that particular event has some sort of misinformation or deception potential.
Right. Yes. That's the whole goal here, is that, in the end, be able to come up with that probability, be able to identify possibly even which arguments or elements behind it that is the explanation behind why this probability is derived.
And the explanation behind it, yeah.
Yeah.
And so, as you suggest in the paper, there are a lot of soft stuff underneath this too. You say, cultures are very different. For example, Asians see their faces in social communications as more important than to Americans, and thus are more likely to have beliefs and exhibit behaviors that can save face, quote unquote. And so whatever training that you might do, the data has to be sort of culturally aware. In other words, it may not generalize across cultures.
Right. I mean, you could think of it as that, the challenge is there a way to normalize that? And that's what we're trying to shoot for. With the cultural things and the cultural elements behind that, here's the one thing in terms of, if we have a process such as, as I said, saving face or something like that, can we identify that as also its own distinct way of reasoning? That doesn't sound quite right, but it does have an effect. What are the impacts on your reasoning chain? What are the impacts on, if I naturally reason out and this is the conclusion I draw, then you could talk about it. It's not that the culture is causing a deception, right? Because I'm not reasoning deliberately to that conclusion. But I can go back and figure out what are the nudges just on a local level of each argument and how arguments combine together that something like culture and saving face is causing on the system.
And this could be a very complex feature set. For example, psychologists propose that clues in non-verbal channels such as facial expressions, movements, or posturing of the tongue and limbs all indicates potentially some level of deception. And so the feature set here may not be just sort of the data that we talked about, but also other type of data like images and other things, right?
Right. I agree.
Um, and again, there is evidence that neuroimaging techniques and brain functions and so on. So yeah, so we have come a long way from sort of looking at data, looking at actions and facial expressions and even brain waves, to basically saying we can actually, given the history of an individual, we could have an ex ante expectation of a process that individual will follow. And if that individual is, deviating from that, there could be something wrong. And that is what's different in what you're trying to do.
Right. Right. Yeah, I think one of the things I guess I'll say it right now. There's a gap, right, between those psychological indicators of nonverbal behavior, all those other elements. That's something that could be quantified to give you some sort of statistical significance that they might be conducting a deception. But like we talked about just a little bit earlier and brought up early on, like the lie detectors and stuff. How does that tie to the intention?
Right.
How do we build up to that? But and I think what you said was right on the point, is that if we can look at, which is what we're doing, if we can look at the process of how the arguments are formed, how the arguments are connected together, or this particular group, and if we have a sense of normalization, right, then we can try and answer at least that intent, whether there's that deception intent involved or not.
Right. Yeah. I was also thinking, Gene, so we have used words for a long time. How you phrase a question, how somebody answers that question, all of that has information. You also say here is that methods beyond word level cues include part of speech tags.
Mm-hmm.
You want to talk a bit about that, how that might complement?
Well, because what happens is that how you phrase something, as you just said, and then how you tag that. So if the tagging is going to be different between the listener and the speaker themselves, and the speaker's aware of that, that's something that they're manipulating. It's a lot like, you say something, with intent not just be ambiguous, but intent to have them interpret a certain way, right? So
Right.
that can complement it, because why did I want them to interpret it this way? I can now start going in intent, as opposed to, something that, okay, that's just kind of, I was just randomly saying things with no concern.
Mm-hmm. Yeah, I don't know how how your students are, Gene, but the next generation seem to use less language, for better or worse. The way that communicate on social networks and elsewhere appears to be sort of a new language almost. So I wonder what those types of trends, what kind of impact it might have on our sort of analytics around around this type of things.
I would say the following. It depends on what is really being communicated. What's the substance of the communications? You can certainly develop a new communication scheme. I can see it, potentially within social media, that even though this might be a whole bunch of symbols and stuff, but if you have symbols and memes and semantics behind them, you're communicating something. So there must be some sort of reasoning pattern that if I'm going to communicate a complex argument or even just a simple argument, those should show up. The course of it makes it very hard is that, well, memes are sort of the classic ones. Is somebody looking at a meme, like I've seen memes, and I'm enough of the previous generation that I have no idea what the heck this meme is, because I don't recognize anybody in it.
Right.
But that meme has a meaning. It's like it's a reference to some historical stuff. So that's it's a lot like what's one of the problems still that is going to be is still a challenge for, say, AI and machine learning and everything like that. Natural language processing on poetry. Right? Because
Right.
there's so much meaning, and there's so much imagery that's mental imagery and everything set up. So that is going to be a challenge. But in the end, though, obviously, if we do crack that, then I think just the whole notion of the arguments and stuff like that will still hold.
Right. Yeah, I tried to convince somebody the other day that we could create a machine that could identify charisma. And I wasn't successful.
That's tough, but actually I'm kind of on your side. I think there's something that can be done with that. At least like when you bring up like the nonverbal cues, the way they go about doing things, their gestures, their movements. I can't remember, but I think there was somebody, like probably a famous actor or somebody like that, in terms of when they have to portray different characters with different charisma, either negative charisma, positive charisma, or no charisma. And that's a lot of, how should I say, expert knowledge or subject matter expert knowledge, which it'd be very interesting, at least for me, to delve into.
Yeah, I will collaborate with you on that. I'm very
sure.
Too. So you have sort of a prescriptive notion here. You say an honest teller's arguments are formed by reasoning on prior knowledge and observations. Computationally, you say it means that the derived arguments are inferred through his knowledge base that encodes the correlation and causality between the knowledge pieces and evidence that includes observations obtained before reasoning. On the other hand, a deceiver's arguments are formed by presupposed conclusions, and the conclusions are false from his point of view. So this sort of saying, the process that an honest teller would use is, if I understand this correctly, is prescriptive. So we could actually say, here's process A and here's process B. If you use process A, the chance of you being honest is a lot higher as opposed to process B. Is that what you're saying?
Yeah. That's the way of looking at that. It's back to another way of thinking of it is, if we look at the space of possible answers, space of possible conclusions that's going on, and if we're doing process A is not, how should I say, beforehand pruning that space or reshaping that space. Yeah. Or process B, if you're trying to force yourself into a conclusion, is pruning that space. Now, one thing I'll bring up, and this I know gets my students very confused, and sometimes when they're confused, they get me confused on it too. It's that, what if we're trying to explain the conclusion, right? If this should be the conclusion, well, there's still a difference here. What I usually say is that you're going to try and explain from the conclusion. You're still going back through the process, and yes, things are being pruned, but what you have left is that what had to be pruned in order to reach this final conclusion you're shooting for. Now we can start comparing the spaces of what needed to be pruned, what was pruned. And so now you have your, sort of going both directions should be the same.
Right. Although I wondered, you could say process B, is sort of not using data in a way that a logical process might use to reach a conclusion. Now, it could be a deceptive way of doing that, but it could also be just the way that person actually processes information, right? I mean, we can see a lot of instances of this now. You say, I believe in X, and then I go look for data to see how I prove X, right? It's going the other direction in many of the arguments that we hear.
Right. So actually, in this case, though, one of the items that we think about for this is that, was there a deceptive intent? That is, they actually know that through their own regular reasoning process, they get this conclusion to be true, but now they want to make sure that conclusion is false to the other person because it benefits them most. So if somebody comes up with their reasoning scheme, that's why I said, we just said about patterns in general, that's okay. That's their pattern. If we had the history of what they've done in the past, that pattern should still be there.
Right. Yeah. So it's really interesting. So you have multiple experiments in this paper. Deception data sets, assumptions, and setup. So the first experiment is measuring patterns given reasoning scheme. This is a hotel data set.
Mhm.
You want to briefly describe what
Yeah,
happens?
so let me just describe the data sets
Yeah,
overall. So
yeah,
the hotel data set was an attempt to try and figure out, can we detect false reviews? I mean, it's a very
mm.
classic problem. This is a nice data set because it is fairly widely available for people to figure out, is this a real review or not?
Like on Expedia or something like that.
Yeah, exactly. Yeah.
Yeah,
So, oh, I'm sorry. I just drew a blank on where we'd gotten this data set. Been lost in the weeds too long in it. But it would be something like either Expedia or TripAdvisor or whatever one of the major companies were.
yeah,
And so what we had was that this data set was a labeled data set from them
mm.
of saying that whether it's false or not. And what we wanted to do, our particular test, is not just matching about the accuracy or things, but
Yeah,
can we apply this argument framework? What were the elements that were brought up in a review? How were they fitted together? What was, for example, some things like the polarity being, hey, did they think that the room was clean? And so that could
mm.
be a positive or negative polarity. And then use that to form the arguments together to see that, all right, what we declared as a false review, a deceptive review, was because of this. So that was the setup for that particular scenario and why we were running as the first experiment.
Yeah. So we have had sentiment analysis for a long time.
Mhm.
And this is going beyond sentiment. You are basically saying what you're trying to do is to assign a probability to an individual who is making that review, making that sentiment, based on that individual's habits, or what is in the review. You can assign a probability that it is actually deceptive.
Yes.
And so it's interesting. Again, it might have some financial markets sort of usage too, right? There are a lot of instances where news come out on a company. There have been instances where somebody puts out a positive news deceptively into the market, and then stock goes up, and then they get out or they short the stock and make money that way. So something like this running on or sort of a news feed could assign some probability that the news is actually true. And more generally, this is what Facebook and everybody else is trying to do in some sense, right? Detecting fake news.
Right. Right. Yeah. I mean, one of the things that had inspired us, this was much earlier work on people trying to detect fraud. And so one of the models that we followed fairly closely was I think it was fraud in accounting, and there was a process of steps that when you look at the fraud in accounting, of how you go about, first of all, when should you trigger a flag that we might need to investigate? How do you go about then if this flag is triggered? Explain why that flag is triggered by looking at some of the elements that seem out of place or inconsistent, and then come up with the explanation of, is this a correct trigger or not, or where is this coming from? And then finally make a decision that, is this truly fraud? Are they manipulating something? So very similar to what you're talking about on the financial news, is that now we have this sort of wealth of data from the domain of, this news is expected to impact in the following way. That would be sort of like your conclusions that you're drawing. From that, you now go back to the arguments of what are some of the elements that we've known historically will impact how whether the stock goes up or goes down, if we want to talk about the stock market. And then come back to that, all right, who's pushing this argument? And also, is this argument structured differently than what we've seen before? Now, one thing I did not talk about is how truthful were the argument elements.
Right.
Yeah, that's the lowest level. That if you do have that also helps out a lot. And that but then of course that comes up with whether you're misinformed or not.
Yeah. So the deception that you're trying to detect is one level above that, right?
Right.
So, just basically putting out lies or putting out incorrect information is one thing, but somebody using a process to strategically manipulate is another, and that is really what you're trying to detect.
Yes, very much so.
And so in conclusion, Gene, are you working on some extensions of this? I can see a lot of applications of this as we get into this election time.
Right.
Are you working on any extensions?
Yeah, we're working on a couple extensions. One in particular is that let's see if we can really automate the argument mining. And the whole notion of the argumentation was also looking at so that, how can I better measure or better understand the structure of the arguments themselves?
Yeah.
And in terms of, what's relevant, what's not. And this is the work. The reason we do that is that then a very simple idea is this, is that if I know the structure and I know the impact of the argument on the structure, then if we know that whether a particular argument is true or false, that tells us something very easy, potentially whether, say, something is fake news or not. This is work in progress. This is one of our hypotheses going forward, but I think it's something that should bear a lot of fruit, just at least based on some of our initial stuff.
Yeah, that sounds fascinating. There could be, I wonder, maybe you're already working on this. There could be a graphical way to represent that structure potentially.
Right. Yep.
So you could, even a human could visually see what that looks like.
Yes. Yeah. I completely agree. That's one of the things that we've been discussing a lot on. Is that it'd be really great that you could throw up says, "Yep, that's an obvious deception. This doesn't look right." Almost like a Rorschach test for deception.
Right. Yeah, there's a lot of it nowadays. So yeah, this has been great, Gene. Thanks so much for spending time with me.
No, thank you also. This was fun.
Yeah, good luck with this research.
Thank you very much also. Good luck.
Thank you. Bye.
Bye-bye.